Welcome to another episode of Power On, the Rennhausen podcast. Today's topic is about aging fleets, renewable integration, and volatile networks. So it's coming that we have transformers in the grid surpassing 50 years since commissioning. Therefore, I have invited a very special guest. It's Alexei Babizki, the head of innovation of solutions. Hi, Alexei.
Hi, Christian. Thank you for your invitation.
Great to have you here, Alexei. The topics I mentioned already in the introduction, that's our common things which we facing in the energy sector. What are the questions that an asset owner is raising to identify critical units in his fleet?
You already mentioned one or two quite big challenges: aging fleet, aging assets in the fleet, not only transformers, the whole fleet. Some transformers in Europe are in average about 40 years, in US countries 45, even close to 50 years. This is, of course, one big challenge. But there are also some recent challenges that appear in the last 2-3 years. The massively increased prices for the transformers and further assets by factor 2, and still very big problems with delivery time. So a lot of utilities and grid operators are forced to let their aged assets in the grid. Nevertheless, it is very, very important to know the condition, for example, of these assets. And there are some trials to do this.
All right. So they want to keep the asset longer in operation or extend the lifetime of that individual asset. Of course, we should also know when is the best moment to send the unit to retirement and replace it with a new one, right?
Yes, replacement is, of course, an important topic, but also lifetime extension measures or repairs. All this information you need to know to plan your budgets, to plan your resources.
We need a clear picture about the installed fleet to plan further measures, to have clear actions and recommendations, and they, of course, must also fit to the available budget.
Yeah, exactly. And perhaps one topic that I can mention is that many utilities in the past, they applied a so-called time-based maintenance strategy. And more people, utilities, responsible asset managers, tend to apply another asset management strategy like condition-based or even risk-based asset management strategy, which of course requires different additional tools and solutions.
To understand it correctly, even for a risk-based approach, I would need a clear picture about the installed fleet, right?
Yeah, of course. A risk can be calculated with a known condition and known criticality. It is a big difference. Is a transformer a very critical one? Then, of course, the risk of a failure will be much, much higher. The same condition for a transformer where their criticality is not as important.
For example, when we compare an HVDC transformer with a very small distribution, as an extreme example, just that everyone gets a clear picture.
Absolutely correct.
Okay, all right. As head of solution and innovation, you and your team work on innovative solutions. How you do find out the correct solution, and how do you and your team ensure that this solution is solving a pain point? Like say.
We work with magic triangle. And what does it mean? That means that, of course, the needs from the utility, from the grid operator, should be taken over and should be analyzed. This is one corner of the rectangle. Of course, also there are possibilities to answer on these needs should be also analyzed. This is the task of an industry. So we are responsible for that. And the solution should be technically and from the scientific point of view also correct. So it is the last corner of a triangle. It should be some universities with a very high expertise and consulting knowledge. And in this kind of triangle, we work quite successful.
We are very close to the market, or your team is very close to the market to talk to partners, utility, asset owners, work together with universities. Then I understood it correctly. this joint development, I would call it like this. This is then really, you get the feedback, but how do you then ensure that all information or a solution that came up is then really helping in the end of the day the asset owner?
Okay, so you talk about the process of development, yeah?
Correct.
So we just, based on one example, we have actually a very big project with almost 40 utilities, grid operators in the DACH region. DACH region means in Germany, Austria, in Switzerland, and with a university. And with us, so we have industry, university, and utilities.
The magic
triangle. Exactly. And we analyze their requirements. We develop a solution, and this solution should be applied in different so-called pilot projects. So, because of course, in the reality, you will get immediately feedback. How does it really work? There are a lot of additional loops in the development because we get this feedback, we can apply this feedback, we can improve, optimize the solutions. And so step by step, we come to the optimum of a solution.
All right. So we stay always, or your team stays always very close and is involved in the entire process chain. You already explained it a little bit, but can you maybe give an example for a partnership, how that really works, this elaboration?
Yes, for example, I think it was 5-6 years ago, we were very, very deep in the development of a condition assessment solution. We work with a German utility and with a university who help us, support us in the methodology, how to do it. We built up a knowledge for the transformers or how they can be assessed. We applied the new solution. We call it minimal viable product. So it shouldn't be a very professional solution in a web application, how it works now, for example. But 5-6 years ago, we worked just with an Excel to make sure that we meet the requirements of this utility, of this partner. And in a pilot project, we could recognize, okay, here and there, some improvements should be done. We did it, and then we came out with a new solution, with a condition assessment, with so-called two-dimensional condition assessment, where we cover operative expenditures, so OPEX, and capital expenditures, CAPEX, two perspectives in the asset management, and help the asset managers to plan their budgets.
To give an example, which costs are considered under CAPEX and which costs would be considered under OPEX?
Approximately, of course. So if we talk about CAPEX, capital expenditures, so we talk, for example, about replacement of a transformer. If we replace a transformer, we talk about millions of euros.
Okay.
We talk, but also about some bigger investments like lifetime extensions measures, bigger retrofit projects, or, for example, a longer oil reclaimment process.
Okay.
Then we talk about hundreds of thousands of euros. On the other side, on the operative expenditures, here we talk about such measures like a maintenance. Or a replacement of a smaller component of a transformer or other asset. And then in this case, we just talk about 5,000, 10,000 euros. So the factors are completely different.
In terms of service developments, what are the outcomes that you and your team and network operators achieve? I also heard that you're currently working on an aging model, something like this?
Yeah, as I already mentioned, 5 years ago, we developed a methodology how to make a condition assessment. So now we are able to say currently the condition of the whole fleet or of an individual transformer is well known. And there are very clear recommendations what should be done now.
Okay.
But till now, there is no prediction in the future. And of course, for the utility, for the general management, for the asset manager, it is very important to know, okay, now the transformer is not in a critical situation, not in a critical field. But what will happen in 5 years, depending on, for example, on the load of the transformer, on the weather where the transformers are located, on the condition, of course, their aging behavior can be different. And in frame of this big project, we develop an algorithm how to see into the future, how to predict the condition of the transformers.
So we know the condition now and can imagine the individual asset depending on the location and environmental aspects into the future.
Yes. So you can say on the fleet level, for example, in 10 years, you have to replace 10% of your transformers, for example, or you should be aware that you have to make an oil reclaimment for 5% of your transformers. And of course, you can immediately consider it in your budget planning.
What if an asset owner, a utility company, decides to use this service? Is it already available?
Yes, the condition assessment is already available in different levels according to the aging behavior. We do now the first pilot projects. We, as I mentioned, we make these development loops to improve the algorithm, to improve the solution itself. And I'm very confident that in the next 1, 2, 3 years, we will come to the market with a very interesting new solution.
Following this on-site data collection, how does it work on-site?
It depends, of course, on the requirements on the utility side. So there are utilities who are very knowledgeable, who have a lot of resources in the field. So they are able to take all the information from the field by themselves with their resources. So they can do, for example, visual inspection and put all the information in the web applications and this solution that we developed. They can put all the electrical measurements, oil samples, thermography, and our experts, transformer experts, are able to collect all this data in the web application, investigate them, and make a very detailed report with very clear recommendations what should be done in the next step. Of course, if some support is needed in the field, we have further solutions, so-called remote solutions, where we can, for example, with some smart glasses, data glasses, which will be delivered to the utility, we can support them immediately in the field. So imagine the guys in the field do not know how to assess a leakage. Is it a very big leakage? Is it a small leakage? Is it very dangerous or not very dangerous? But from Regensburg, from the central part in Rheinhausen, we can switch to Australia, to every part of the world, and help digitally. We can help our partners.
If, for example, they have limited resources, would it be also possible that we support them?
Yes,
Okay.
it is possible. Also, in different regions, we are able to make all visual inspection, electrical measurements, all oil samples. Our service technicians would do it and collect all the information, and our transformer experts would generate their reports.
Most of utilities asset owners know the traditional way of an health index. So what is the major benefit when I would go with a smarter solution you mentioned?
This was of one crucial findings that we analyzed many years ago, as we recognized, okay, what does it mean, one health index? Does it help it you really if you get a number 72 for one transformer or for the whole fleet? Is it enough to make
A clear decision.
A clear decision in the asset management? And we could recognize and get a lot of response from our partners. No, it is not enough, because the asset manager and the service manager, they have, for example, completely different perspective.
Okay.
The asset manager is more strategically, service manager is more on operative side. So this is the first differentiation. Then, of course, if they get an information, an index, what does it mean? Do you have to act immediately? For example, if we recognize a hotspot and a bushing, then you have to act quite fast in order to get rid of this problem. If you recognize that your oil in the transformer has an increased moisture, you have more time. Of course, you have to act, but in this...
It's less critical.
Yeah,
okay,
exactly. It depends, of course, on the level of the moisture, of course. But in general, I just wanted to differentiate between these different perspectives. A responsible service manager, he needs a clear view what is the condition of your transformer. He needs a very clear recommendation what should be done, what kind of measures to improve the condition, and he should get the information when it should be done, so the criticality.
Or a briefer, for example, silica gel is already used. You have to act, of course, but the transformer will not immediately fail.
Yeah, exactly.
We analyzed the data, your team analyzed it, and then came out with a different approach. So we give then clear recommendations and actions. It's not just, okay, bushing is critical. Maybe you can give a concrete example of a project where you have been involved recently?
Yeah, you mentioned bushing. We recognized, for example, during a thermography analysis, that a bushing has, for example, a hotspot. So the link between the bushing and the winding is not good enough. So the temperature is increased, and you can see it only with a thermography. Or we could recognize that the oil in the bushing was not filled up, lost some oil.
Okay, visually no leakage, they looked good, but with the thermography you could see a lower oil level.
Yeah, exactly. And then is the question, what should be done? How fast? Of course, our experts make, in this case, quite a simple recommendation to replace this type of bushings. We could recognize that this type of bushings in different transformers in this utility, in the substation, has been used, and we can recognize this a similar problem in many transformers. So, for example, a strategic decision from the asset manager was to replace all the bushings.
And you mentioned there are hundreds of examples. Of course, we cannot mention everything, but we can also then say, in other words, there are hundreds of saved transformers which could get recognized, the failures or the abnormalities, solved it. So, in other words, saved the transformers.
Yes, at least improved the condition, and at least we could be very successful in lifetime extension of the transformer. We recognize, for example, that the moisture in the paper is increased. You know for sure that if moisture is increased, then the lifetime of a transformer will be immediately reduced by factors. And if you are willing to let your transformer for a longer period of time in the grid, it makes sense to make a drying process of the paper. It's a long timing process. Can be done online. It has been done also online. And then in this case, you can just increase the lifetime of a transformer, which is extremely helpful for the grid operator.
Imagine I'm an asset owner. I'm responsible for 600 transformers. For some, I lost the transformer book, or I have no clue about the real condition. Some are new, some are mid-aged. What would be the recommendation of an expert? What I have to do to get a clear picture of my
So this is, of course, we talk about so-called data uncertainty. Data uncertainty is not good. So you have to reduce the data uncertainty. That means you have to collect as much information as possible and as it is necessary, and also from the financial point of view, it makes sense. Of course, transformer books, this is one kind of data source. You can make a visual inspection, you can make a oil analysis, you can make a thermography, and with this package of information, you can already be able to make a very reliable condition assessment with quite a low data uncertainty. And if there are some suspicious cases where we could recognize some increased TGA values or some hotspots in the bushing, for example, then we could apply electrical measurements to commit these results and make a very clear
have a deeper look then. Would you recommend it just for the older units or for the entire fleet?
In a periodic way, it is, of course, for necessary for the whole fleet. There are also very clear recommendations, not only from SIGRE and some committees, but also inside of a utility. There are some regulation frames to do it. And of course, if you recognize that some conditions are already not very good, you have to increase the frequency
Of course, yeah.
Of the condition assessment. Yeah.
Or maybe install a monitoring system.
Yeah, this is one of a solution of possible solution. Yes, to get an online monitoring system. Yes.
Alexei, thank you very much for all the inside stories you gave us today. Also the expert knowledge you shared with us. Thank you.
Thank you very much, Christian, for the invitation.
To everyone who is listening and watching, I would also to say thank you for your time. I hope you gained a lot of knowledge and had fun. Stay tuned for the next upcoming episode of Power On, the Rheinhausen podcast. See you.